What's up you guys, Aditi? Welcome back to our channel. I have already spoken about the invasive and non-invasive techniques in last Friday's video. So if you want to know all the methods of studying the brain, then go watch the video as well. I will leave the link of that video in the end of this video, so stay till the end. And let me just give a little disclaimer that this video and last Friday's video is just an introduction. It's basically a beginner crash course kind of a thing for first year psychology students. So if you are a medical student or a doctor or maybe MA, MSc in psychology student or a psychologist even, then please don't come at me in the comments saying कि ये नहीं mention किया, वो नहीं mention किया, वगैरह वगैरह, because this is just like an introductory videos for first year psychology students. So in today's video, we are going to look at the various neuroimaging techniques that allows us to see what is going on in the brain as a whole. So let's begin. Scientists earlier had to wait till a person died so that they can see if there were any changes or damage in the brain. But thankfully, fortunately, because of various neuroimaging techniques, they allow us to see what's in the brain, like look inside the brain without causing any harm to the person. So one such technique is where it takes a series of x-rays of the brain with the help of a computer. So this technique is called as CT scan. CT stands for computed tomography, or mapping of the brain with the help of a computer. CT scan can show stroke damage, tumors, injuries and abnormal brain structure. CT scan is useful, but it doesn't give all the small details within the brain, which a relatively new technique called as magnetic resonance imaging or MRI does. So MRI actually gives us all these small details. It even allows the doctors to see the effects of very small strokes. A person getting an MRI scan is placed inside a machine that generates a powerful magnetic field to align hydrogen atoms in the brain tissues. The magnetic field allows the computer to create three-dimensional image of the brain, which is displayed on a computer screen. Now, MRI scans only gives us the structure, it shows us the brain structure. So there is another technique called as functional MRI or fMRI, in which the computer makes a sort of a story of changes in the activity of the brain using images from different time periods. This shows how the computer tracks the changes in the oxygen levels of the blood, which provides information on the brain's function as well. So by detecting where the oxygen is being used in the brain, researchers can identify what areas of the brain are most effective during specific tasks. Another fascinating technique that uses MRI technology is diffusion tensor imaging or DTI. Our brain has two distinct color regions. One is gray matter, second is white matter. I've already spoken and I've given a lot of explanation, and I've explained this really well in the different parts of the brain video. So DTI uses MRI technology to provide a way to measure connectivity in the brain by imaging these white matter tracts. So this technique has been used to investigate normal function such as structural changes associated with different levels of memory performance and various disorders and conditions including Alzheimer's disease, multiple sclerosis and traumatic brain injury. Another technique that we'll talk about is PET scan. So in PET scan, the person is injected with radioactive glucose. Glucose is a kind of a sugar. The computer detects the activity of the brain cells by looking at which cells are using up the radioactive glucose and projecting that image of that activity onto a monitor. Computer uses colors to indicate different levels of brain activity. So for example, if the computer is showing light colors, it means there is greater activity in the brain. So PET scan is a great way to see the brain in action. Researchers can actually have a person perform different tasks while the computer shows what his or her brain is doing during that task. There is another technique which is related to PET scan is single photon emission computed tomography, which measures brain blood flow and takes advantage of more easily obtainable tracers than those used for PET. The next technique we'll look at is EEG or electroencephalograph. This device allows us to study the activity of the living brain by recording the electrical activity of the cortex that is just below the skull. So, small metal discs called microelectrodes are placed directly on the skin covering the skull, using a jelly-like substance to help conductor the electrical messages from the neurons just below. These microelectrodes are attached to wires, and these wires are attached to these pens that are just resting on the graph. So when these microelectrodes detect the electrical activity of the brain, these pens start moving up and down on the graph, and that causes these squiggly lines or waves. Now these microelectrodes are connected to an amplifier and then to a computer to view these waves. These squiggly lines or waves indicate many things, such as stages of sleep, seizures, and even presence of tumors. EEG can be used to learn activities of the brain when a person is doing tasks like reading, speaking, writing. So these waves can be differentiated based on different brain activity. For example, very fast irregular waves are called beta waves or beta waves, which indicate waking activity. Slightly more regular and slower waves called alpha waves are a sign of relaxation, and much slower, larger waves are called as delta waves, which indicate deep stage of sleep. There are two other techniques that are based on EEG. The first one we'll talk about is independent component analysis, ICA. This process allows identification of individual signals coming from different areas of the brain. So ICA allows a more detailed and precise interpretation of the signals coming from different areas of the brain's surface. And the second technique is event-related potential or ERP. In ERP, multiple presentations of a stimulus are measured during an EEG and then averaged to remove the variations in the ongoing brain activity that is normally recorded during the EEG. Next technique we'll talk about is magnetoencephalography or MEG. This technique uses devices that are very sensitive to magnetic fields called superconducting quantum interference devices, which are contained in a helmet-like device that is placed over the individual head. MEG has many applications, and it is based to differentiate dementia disorders and to explore cognitive processes in autism. I'll say this again, if you want to know all the methods of studying the brain, then you should definitely check out last Friday's video. But before you leave, don't forget to give this video a big thumbs up. Comment down below what other videos you want me to do, and subscribe to this channel, join the community, hit the bell notification so you'll be notified every time I post a new video. I'll see you next Friday with another psychology video. Another fascinating technique which uses MRI technology is diffuser